So here we've got a couple of problems that maybe at first glance don't look the same. Let me first point out what is the same, which leads to a class of problems, and then solving those is actually fairly simple. Tom can make a basket 3 out of 10 times. That means Tom has a 3/10 chance of success. Focus on that. He has a 3 out of 10 chance of success. It says make a basket. We have to assume that means every single time, 3 out of 10, right? Success is constant, right? That probability doesn't change. And then the question becomes, what's the probability he'll make 6 baskets in the next 10 tries, right? We could do the average, right? We know he makes 3 out of 10. So if he goes 10 times, he'll have an average of 3. That's not what it asks. It's not asking for the expected value. It's asking for what's the chance he makes all 6, right? He could make all 10. He could make 0 of them, and he could make anything in between. There are 11 possibilities. 0 and then 1 through 10 makes 11 possible results. They all have to have some probability and add up to 1. When you have success failure as your options and they remain constant, and you're asked about a probability of a certain result out of a certain number of tries, that's called binomial probability. So you need to recognize binomial probability. Okay? When it's certain number of tries, hey, what's the chance of whatever success is? And you look and you go, oh, success is defined by a certain percentage every time. Coin flipping, half and half, right? Basket shooting, 3 out of 10 succeed, 7 out of 10 fail. I'm going to teach you the brutal, quick way to get it done, which is your calculator. You simply find the correct keys on your calculator. This is called binomial probability. So make sure that on the ETS simulated calculator, TI-84 Plus, I think, make sure you know how to find binomial PDF. That's what you're looking for. Binomial PDF. And binomial is the probability distribution, the type of probability. P means point. DF means distribution function. So it's a binomial probability distribution for a single point. And what we mean by single point is 6 baskets in the next tries, right? We're being asked about 6 baskets. And this is how it enters, right? We're trying 10 times. We have a probability of success of 0.3, and we're wondering how to get exactly 4. The chance of succeeding exactly 4 times of 10 when success has a probability of 0.3. Any problem that is binomial can be broken down that way. So this other problem, a true-false test, 6 questions. What's the probability of getting exactly 4 correct? Oh, right? It's pretty simple. It has to be binomial PDF. Well, we have 6 items. There's the chance of getting a true false correct is 1/2, so we put in 0.5. By the way, you could put 1/2 the fraction in if you wanted to. Calculator can handle it. And 4 is the exact number that we want to compute. And we hit that on the calculator and boom, out comes the answer. I'm being practical here. There is a way to conceptually understand this in terms of how many of combinations and then exponents for probabilities for each of the powers. I'm not going to get into it. You can study that, or you can set up an appointment with your instructor to delve into the underlying derivation of the formula. But for practical purposes, your job is to recognize its binomial probability. I will add one more calculator talent. If it's If you've got a scenario where it's 4 or less successes, 6 or less successes, up to 6 successes, I'd like you to think of that as an integral. It's sort of like an integral from 0 successes to 6 successes, an integral from 0 successes to 4 successes. So when you're adding up the cumulative probabilities, that's called binomial CDF. So use binomial CDF is used for problems where, here, let me make the typing, where you want the probability of the number of successes or less, right? What's the chance of getting up to 4 of these problems exactly correct? Oh, okay, up to 4, up to and including 4. That would mean binomial CDF 6.05, 4. All you did is change the P to C. All you did is look up a slightly different formula on the calculator. If the basket question was he will make 6 or less baskets, then it would simply be binomial CDF 10, 0.3, 4. You're adding up that number of successes and 5 and 4 and 3 and 2 and 1 and 0. And the only neat trick is if it asks for something like, what's the chance of between 2 and 6 successes, including 2 and 6? Well, I mean, you could add up exactly 2, exactly 3, exactly 4, exactly 5, exactly 6, and write them each down. But it's probably easier just to go cumulative 0 to 6, and then subtract off cumulative 0 and 1, right? Do a cumulative up to 6, and then do a cumulative up to 1, and subtract. So all that's left is 2, 3, 4, 5, or 6 successes. So that's the only final trick to think of. If they give you a range, it might be easier to compute the difference, almost like integration from Calc 2. And the other note here is if you had to do it by hand, you might care that, oh, 6 or less baskets, that's 7 different answers. Wouldn't it be easier by hand to figure out 7, 8, 9, and 10 correct? And then simply succeed, and then simply subtract from 1? Yes, you could do that. But in an era where you can use a calculator to instantly compute, you probably don't need tricks like that. You only need tricks like that if you're going to do it by hand with the by hand formulas, which I don't recommend, but I'm perfectly happy to teach if you so desire. So there you go. Recognize binomials. Repeated trials of a single event where the probability remains constant for success and failure. And the question is generally, hey, what's the chance of getting this number of things as successes out of this number of tries? Binomial PDF and CDF if it's a cumulative, 0 through whatever number of tries successful, or number or less successful.